What's up everyone? I'm still in shock that my last video about agentic engineering got hundreds of thousands of views. I'm really happy to see many of you are leaning into building with agents, and I plan to continue sharing what I found that's truly useful for getting real work done. Today, by popular demand, I'm going to be sharing my entire development environment by setting up all my config files from scratch, step by step, so we can all go from a freshly installed Mac to my complete agentic engineering setup that's ready to go. Let's get started. Alright, here we are at our starting point, a freshly installed Mac OS on my Mac mini. I have only done some of the most basic things like installing Chrome, Git, and set up my SSH key for GitHub. I also downloaded this custom wallpaper here just so the video looks a little bit more pleasant. I will drop a link in the description for where I got this. And that's all there is right now. We will set up everything else together from this point on. Now, the very first problem I want to solve is the reproducibility of my configuration. It means once I have things all set up on this machine, can I easily apply it on another machine and get the exact same results? Or, in the less likely but still very possible scenario, if my AI agent did something stupid and completely destroyed my system, can I recover it instantly and get everything back exactly the way they were? My solution to this is something called nix. If you haven't heard of nix before, nix is a declarative and reproducible configuration system primarily designed for Nix OS, which is an operating system based on Linux. But you don't have to use Linux to use nix. People have made nix portable, and here's an installer that works on Mac as well, called determinate nix. And this is what we will install now by following their install command here. So this is what we will copy. We'll just run this command in our terminal and finish the installation here. We will choose yes. Now it says the installation is done. So let's follow its instruction and let's copy this command and we will run it. This will basically refresh our environment. Alright, now Nix is properly set up in our environments. Let's start writing our actual .file config. I'll go create a repo here in my GitHub control-GUID, and I'll make a new repo called .files. And I will initialize Git here. This will be the repo I publish on GitHub after this video. And I'm going to create a symbolic link at a fixed location here like this. I'll be targeting this current directory and I'll put a symbolic link at this location. I do this so that all my scripts later can reference this using a stable path. Alright, now we have an empty .files repo and nix already set up. The first config we write here is going to be something called nix-darwin. Nix-darwin is how I configure my Mac OS settings using nix. You will see how it works in a bit. But for now, I'm just going to be copying their boilerplate config content here. And then let's go create a nix file called flake.nix. We don't have Neovim just yet, so I'm just going to use the vanilla Vim that comes with the macOS install for now. It's not as good, but should be enough to carry us through the initial phase until we have Neovim set up. I'm pasting the boilerplates in as is. This file basically just tells Nix where to get the packages, where to get nix-darwin as well. We don't really need to worry too much about this file. The only thing we need to change is that I'm not John. So I'm going to call this .files. And there is another John here. Let's just name this whole thing Mac. And something I do want to change is that I want to pin the version from the current unstable version to a stable version, to at least a pinned version number. So I'm going to copy this and I'm going to replace that. And I will do the same for this as well. Okay. So this will basically allow us to have a stable version that we will be using, so we don't get surprises. And then we're going to create this configuration.nix file that's being referenced here. So what I'll do is I'll do configuration.nix. To save us some time, for the rest of this video, I'm not going to literally type in every character one by one. That will be too slow. I'm going to paste the snippets in and talk through how they work. Here's the file contents that we actually need for now. It's very simple. And we set nix.enable equals to false because we are already letting determinate manage the nix installation for us. We don't need to repeat a nix installation here. Allow unfree basically allows us to install programs from Nix that are not completely free. And host platform refers to the architecture of the current system. My Mac here is on Apple Silicon, so I set this value. If you are running a Mac that uses Intel CPU, then you will set the other value. Primary user is basically just my username. And state version here is a version number for the default state values. Generally, we just set it at 6 and just never touch it again. That's it, our initial nix-darwin configuration. The way to activate it is by first tracking everything under git. And then we will be running this command. This will basically install all the missing dependencies and apply the configuration onto the current system. The first time you do this is going to take some time, so just be patient and wait for it to be done. This process of applying our Nix configuration onto the system will need to be repeated every time we change our Nix config. So I'm going to create a helper script here to make that easier. We'll call this rebuild.sh. And basically, it will just repeat what we did earlier. We're going to make this executable as well. Rebuild. And moving forward, every time we want to apply a updated Nix config, we can just run it like this. And it will do the same thing. All right, although we applied our Nix config, nothing actually changed about our system because we haven't set anything meaningful yet. Time to do some real settings. Now let's get back to our configuration.nix file. And we will be pasting this snippet in. This will set a lot of my preferences that I would otherwise have to click through in the Mac settings. So there is dark theme, there is fast key repeat, there is short delay before repeat, there is auto hiding the menu bar, there is always showing the file extensions, there is auto hiding the dock, and using list view for Finder, and have a clean desktop that shows nothing on it except the wallpaper, and making tapping on the trackpad click it. You can pretty much set anything you want about your Mac system through this configuration, and you can find all the settings in the nix-darwin repo. Now let's rebuild and see that apply. You can see our dock already changed the behavior as a result. So now the dock is hiding itself. Next thing is to install the apps that we need. On Mac, a lot of the useful apps can be installed through Homebrew. So let's get Homebrew installed first. We could just go to the Homebrew website and copy-paste their install command and get Homebrew installed, but that's not going to be reproducible. Next time we set up a new machine, we would have to manually go do that again. To make everything reproducible, we should do it the Nix way. And the way to do it is to install Homebrew as a Nix package. The package is called Nix Homebrew, and here's the repo. It has detailed instructions for how to set it up. We need to modify our flake.nix file. So we'll come here and go to flake.nix. And the main pieces we need to add is this input here, and also add this module. Now we can get back to our configuration.nix file and add Homebrew configuration in. This will basically just get Homebrew installed, and this cleanup setting here, cleanup equals to zap, basically says each time we rebuild our Nix configuration, it will remove Homebrew packages that aren't listed in our Nix config. This is a useful setting because it's going to force us to install every Homebrew package through our Nix config instead of ad hoc. And if everything is installed through Nix, we know the whole system is reproducible. I also listed casks here to install. And for now, I just added WezTerm, which is the terminal emulator I will be using. Other Homebrew casks you want to install should also go here as well. Now let's go run a rebuild, which should get Homebrew set up for us. And we can verify by running brew --version, and it's working. We now also have WezTerm installed. So let's get it open. So now it's time to close the default terminal, and I'll be using WezTerm moving forward. Besides Homebrew, another very important tool we need to use is called Home Manager. Unlike nix-darwin, which manages Mac OS level settings, Home Manager manages everything that belongs to our user directory, aka home directory. Similar to Homebrew, we'll first go to our flake.nix file, and we'll be first adding in Home Manager as an input like this. And then we also need to add it as a module here. And we need to make sure it's listed here as well. All right. And this last line here, this is the key. This is basically saying for this username, we will use the home.nix file to manage it. And this reminds me that we actually need to edit the configuration.nix file here as well. And we need to make sure this section exists. This basically sets the home directory for this user correctly. Otherwise, it will not work. And then we're going to be creating this home.nix file that we mentioned earlier. Here's the initial contents we'll be putting in. You'll want to update your username to whatever you actually use. And the interesting bit here is this line, where we created a symbolic link for WezTerm's config directory. This basically says we should create a symbolic link at the current user's home directory .config/WezTerm that points to this path in our .files repo. This is how we store configuration in our .files repo and have them automatically used by the actual programs. And because this whole directory is a symbolic link, if WezTerm update any of its configuration at runtime, those updates will reflect in our .files repo as well. So all the config changes will be version controlled, which is really useful. And remember earlier, we created a symbolic link at this location in our home directory. This is how we make use of it. We can just always use this path to find our .files, regardless of where the actual git clone is. Now, the next set of things we add to Home Manager is a list of packages that we want to install at user level, and we can just let Home Manager install all of them for us. Interestingly, even fonts can be installed by Home Manager this way. Here we're installing the Hack Nerd font, which is my favorite monospace font for terminal and coding. We install it through Home Manager here, so we don't need to manually click through and download the font from their website. We can also set environment variables like this. So for example, I want my default editor to be Neovim. So here I have this variable set. Let's run another rebuild. And remember to add all the files to be tracked by Git as well. And we'll be rebuilding. Before we go deep into configurations, I just want to get one last thing set up, which is our shell. By default, Mac already gave us the Z shell, which is pretty good, but it's the raw Z shell without any of the good stuff. And I need the good stuff. So we'll come to our Home Manager config again, home.nix, and we will be dropping this in. This enables auto suggestion, which will give us ghost text auto-completion for shell commands based on what is in our command history. It also enables syntax highlighting, which is very useful. The init content here basically just gets pasted into zshell's RC file directly. And this line will give me a key bind so that I can press Ctrl F to accept the ghost text suggestions, which I'll show you in a bit. And then I set a bunch of shell aliases here. This just makes some of the most common commands I type a lot shorter, which saves a few seconds each time, and it will add up. When I die, it's going to feel awesome knowing that these aliases gave me a few more hours of life. Alright, let's go rebuild our Nix config again. And let's now start a new WezTerm session. Now you can see this auto suggestions already kicking in, and syntax highlighting is working correctly as well. Another thing that will greatly improve our shell experience is Starship. It's a program that lets you customize your shell prompt, which is this whole prefix before my cursor here. The system default is just really ugly. Let's get back to our home manager config and add in this additional snippet. This gets Home Manager to install Starship for us and puts in some basic customization. Here I'll just keep it simple for now, but Starship is very powerful and you can do a lot more customization on your own. If we rebuild now and we start yet another clean WezTerm session, we can see we have a much cleaner shell prompt here. The next big upgrade that will greatly improve our experience is to configure WezTerm. I introduced WezTerm briefly in my last video. It's a highly performant terminal emulator written in Rust. And the part I like the most about WezTerm is that it's truly cross-platform. Even if I get forced to use Windows from time to time, I can still bring WezTerm with me and it will give me a consistent experience there. And it's highly customizable through Lua scripts. Let's create the config file for WezTerm. First, we should make sure the directory exists. So it should be this directory, right. And let's then create the file. And let's start with just this minimal content. This WezTerm.lua file basically just needs to return an object that contains the config values. This basically just uses the default for everything. If we save this and we restart WezTerm, we can see that nothing actually changes. But now we can just write whatever logic we want to modify the config object. Let's start with my favorite color scheme, Rose Pie Moon. And if we save, you can see WezTerm would hot reload the configuration and it will immediately take effect. Next, I will change the font to be Hack Nerd font, font size 15, and save. The experience just keeps getting better as we start to modify more and more of the configs. Let's also adjust the window background opacity and blur, and save. Let's also hide the tab bar when there's only one tab, and let's get rid of the window frame altogether. Let's save. Now we have a super clean frameless terminal window that's basically entirely used to render whatever content we care about. Look how beautiful this is. I really care about making my development experience pleasant, because if I enjoy the experience, I will stay focused more easily and end up doing better work with it. Now that our terminal looks good, let's get to the big boss, Neovim. Neovim is my primary code editor, so it's a really important thing to set up well. Its configuration starts with an init.lua file in the config.neovim nvim directory. So let's make sure the directory exists. And then let's set up the file as well. And now we can actually use Neovim to edit Neovim config. So let's go to create the init.lua file. Let's leave the file empty for now, and we will go to home.nix. And just like before, we need to create a symbolic link here, so that the Neovim config can come from our dotfiles repo. And now let's rebuild the Nix config. And we will start Neovim to make sure it still loads. Let's see. Yep, it still loads. Okay. Now in this init.lua file, I'll just ask it to require other files. I'll start with requiring vim config. This is how I structure my Neovim config in a modular way, so different things live in different files. When you require a module in Lua, it will go look for the file under a directory called Lua. So I'm going to create this directory from there. And I'm going to create the actual vim config.lua file that we said we will have. Yep, this is Neovim complaining that the file we are requiring from init.lua doesn't exist yet, which is as expected. I'll be pasting in this configuration to start with. These are some sensible defaults for a typical Neovim experience. The map leader here basically configures the leader key, and I have set it to be space key. So later when we configure keybinds, we will make use of this. This line expands tabs into spaces. Should we go down this rabbit hole here? Probably not. This makes each indent level 2 spaces. This renders the current line number, and this enables relative line numbers. Actually, let me stop here and show you what that is. I will restart Neovim and reload this same config file. You can see now on the left side of the editor, we have all these line numbers. The one on the same line as the cursor is the current line number. This is the 7th line of the file. If I move my cursor to another line, say GG, which goes to the first line, I can go back to the previous line by typing :7, and I will arrive at the 7th line again. You can also see all these relative line numbers above and below 7. They indicate how many lines are they away from the current line. The way I use this is when I need to jump to another line, let's say the line with map leader. I can see it's 5 lines above the current line, so I can just type 5k, which means repeat k 5 times. And because k in Vim motion is moving the cursor up, 5k just let me arrive at the line very easily. That's how I actually use relative line numbers to very quickly jump around. Then we have ignore case during search by default. Smart case means if I typed a capital letter, then it becomes a case-sensitive search. Clipboard, unnamed plus, somehow means using the system clipboard for copying and pasting. Scroll off here means at least reserve 16 lines between my cursor and the edge of the screen when I scroll. So I always have some visibility what's above and below my cursor line. This undo file basically allows undo and redo to be persistent across Neovim sessions, which is very useful. There are a lot more Vim options available. Whenever I need to change something that's about the Vim behavior, I set it in this file. So it's all centralized and easy to find. The other file that we will require from the init.lua file, let's go back to init.lua. That's going to be plugins. One of the biggest advantages of Neovim over vanilla Vim is its rich plugin ecosystem. There are so many great plugins available, and I use a plugin manager called Lazy to help me install and update them. This is probably the most widely adopted plugin manager for Neovim right now, written by a legend named Folky. You can follow this repo's instructions to set it up. I will just paste the boilerplate into my config. Here. It's just a short snippet of setup script. The last line here tells Lazy to load every file in a subdirectory called plugins. So we are going to create that directory now. And now let's set up the first plugin. One thing that's not very convenient in the out-of-the-box Neovim experience is that if I need to quickly jump to another file, even if I know its name, it's not very easy. The same guy Folky wrote a lot of other great Neovim plugins as well, one of which is called Snacks, and it has a bunch of really useful utilities that help with things like that. So here, let's create a file called navigation in the plugins directory we just created, navigation.lua. And I'll paste in a plugin spec here to install Snacks. This basically means the plugin is a GitHub repo hosted at folky/snacks.nvim. And priority means it's priority during Neovim's initialization. I'm actually not sure if this is still needed, but at some point I set it to 1,000. So I'm just gonna stick with that for now. Don't fix something that's working, right? Lazy equals false means we don't lazy load this plugin. Some plugins can be lazy loaded to minimize the burden during Neovim's initial startup sequence, but this one does need to be loaded upfront. OPTS, this is an object where we set options for the plugin. This is plugin dependent, so every plugin has different things you can set. For Snacks, this is where we decide which utilities we actually need. Here I enabled picker, notifier, and input. You can go to its GitHub repo if you are curious what they do, and what else it has. And at the end, I set some keybinds. This means if I press leader key and then F, it will trigger the file picker. Leader S will be the grep picker, and leader B will be the buffers picker. Buffers in Neovim are kind of like what files you have open, kind of. I also use GD to go to definition. Okay, now if I reload Neovim, we'll see Lazy knows that we have a new plugin configured that's not installed yet, so it's installing for us. And after it's installed, we can use the keybinds we set to invoke the plugins. I can use space F to bring up the file picker here. And here you can see we can filter by the file name. We can now also use space S to do grep, so I can find which files contains the word nix. But sometimes I don't remember what the file names are and what keywords to look for. I just need a file tree to browse the file system. But where is the file tree? That's another plugin we'll go install now. If you are new to Neovim, I think by now you are starting to get this philosophy. It's a highly extensible system, which comes with a minimal set of features and lets you customize and extend it by yourself. So everyone's Neovim may look a little bit different or very different, because everyone's assembling a different set of plugins with different customizations layered on top. My favorite file tree plugin is called Oil. And because this is also about navigation, I'm just going to use the same navigation file here. And I'll paste it into this navigation.lua file. Very simple configuration. Basically, I just set it to show hidden files and gave a keybind that is leader key followed by E. So let's restart Neovim to try it out. All right, it's installed. Leader E. And now we can see this little file explorer-ish kind of view here. The beauty of Oil is that it puts the file system into a normal editable buffer and lets you view and modify the file system just like how you edit any content in Neovim. So let's look at this file. And let's say I want to make a copy of this configuration.nix file. What I can do with Oil is that I can press YY, which means copy current line of text in Neovim, and then P, which means paste it. And now there are two configuration.nix file which will conflict. So let's give this new one a different name. Let's say configuration-2. And now if I do :W to write this buffer, you can see it is actually trying to copy this file. This is oil.neovim recognizing my intent. And I just confirmed. You can see it actually created this configuration-2.nix file here. And it's a copy-paste of the previous one. Similarly, if I go to Oil and delete this line by typing dd, and I write, and the file is gone. If you are used to editing in Vim, you will feel this is a really natural way to handle the file system. It's my favorite way to manage files. Now, with agentic engineering becoming my primary way of coding, I find that a very common reason I come to Neovim is to quickly review diffs and manage the state of Git. But there's nothing out of the box in Neovim that can help me do that. I use two plugins called NeoGit and Git Signs. I'm going to create another file here called git.lua, and I'm going to paste them in. Very straightforward. Basically just giving a keybind to launch NeoGit and an option for Git signs to show the Git blame of the current line, so it's easy for me to see who's the person that last touched it. Here you can also see this event equals buff win enter. It's a primitive in the lazy plugin manager, which means only load this plugin when this event happens. And this event means when we actually enter a buffer. You can do a lot of optimizations like this to speed up your Neovim experience by loading things only when they are needed. If we reload Neovim and let Lazy install the plugin for us and launch NeoGit by using the keybind, we can see we now have a very helpful tool to see and operate on the code changes tracked by Git. I use this a lot to review diffs. And to stage changes I have reviewed and feel good about. Now that we have a few plugins that need to be launched by a keybind, sometimes we might forget which key is for what. This is where I rely on a plugin called which-key. Let's put it under a UI.lua file, and I'll paste it here. Surprise, surprise, it's also written by our guy, Folky. Let's just install it and I'll show you what it does. Now, if I press the leader key, which is space, you can see this pop-up at the bottom that shows what I can press next. This is particularly helpful when you just added a new plugin or a new keybind that you haven't built the muscle memory around yet. Speaking of keybinds, I do have a few special keybinds that are very convenient. Let me go to the init.lua file so that we can add in one more require, which is going to be keys. And that is going to be where we store all the keybind related configuration. And these are my favorite keybinds. I'll show you after a reload. The first one here makes ESC save the file. The reason I really like this is that normally to make edits in Neovim, you have to enter insert mode like this, and then you can type whatever you want. And after making edit, I typically need to come back to normal mode so I can move my cursor around to other places, right? And the way to get back to normal mode from insert mode is pressing ESC. And guess what? That is the same moment when I typically will want to save the file. So with this keybind, I can just spam ESC whenever I have done some useful edits and I want to save. That's very convenient. The next one is a no-brainer. In almost every editor, Ctrl A is selecting all. So this keybind just replicates the same shortcut in Neovim. The last one here is an interesting one. Let me keep it disabled so I can show you the difference. It's best that I show you live because it's not clear from the command at all. Let's say I select a few characters here, VIM, and I press Y, which means yank, and that's Neovim's way of saying copy. I basically just copied those 3 characters into my clipboard. Now, if I go select a few other characters, and I press P, which means paste, you will see that it's done a replacement. Now, if I go to select a few other characters and press P again, what do you think will happen? It should get replaced by VIM again, right? Nope, it's all messed up now. This is one of the counterintuitive default behaviors in Vim because of how the registers work. So this keybind here basically just fixes that behavior by stopping the replacement actions from messing up with the clipboard. It just makes the experience much more intuitive for me. Alright, there is a whole bunch of other things I can go into about Neovim, like LSP and tree sitter, but there are actually plenty of good videos out there showing specifically how to make those things work well. So I'll leave that for you to explore by yourself and skip ahead to a very important chapter, which is about managing terminal sessions. Up until now, we're just setting some config files, and we do it one at a time. But as soon as you start to work with agents, you will need to manage multiple agent sessions in parallel. When one agent is working, you will need to kick off another. When one agent is done, you might want to launch Neovim to review its output. In a regular terminal window, it's hard to do that. This is where terminal multiplexers come in. They allow you to create sessions, windows, tabs, and splitting tabs into panes, etc., etc. A really popular option here is tmux, which literally means terminal multiplexer, and is probably the OG. I showed it briefly in my previous video. WezTerm also comes with multiplexing functionality out of the box. But recently, I have come across something better called Herdr. The best thing about it is that it's built in this agent era. It understands what agents are, how they work, and integrated with most of the mainstream agent harnesses really well. I have been using tmux for years and years, so moving to a different system was not an easy decision. But now that I have used Herdr for a few weeks, I can confidently say it gives a better experience. It also might be the only terminal multiplexer that works on Windows as well. So if you are on Windows, this is very much worth trying out. So let's set it up. Let's go to our Homebrew configuration in this configuration.nix file. And instead of casks, it's a normal brew. So we will copy that here and list it here. And now let's also create this configuration directory. Let's also go create the config file for it, and it's at this location, config.toml. And let's paste it in. These are pretty much just keybinds that allow me to preserve my muscle memory in Tmux. If you haven't used Tmux before, you might be able to just rely on the defaults instead. And similarly to other config directories, let's create a symbolic link so that we can apply the directory. All right. Now let's rebuild Nix. Now let's get into Herdr. Here. You can see it has a side panel on the left where it organizes your workspaces and agents, and a main area that is similar to our default terminal experience. Now I can use the keybinds we set earlier to create new tabs like this. I can name the tab as well. I can say dotfiles as well. And I can split a tab into panes like this and like this. These are just basics that Tmux can do as well. What's really cool about Herdr is that its integration with agent harnesses is really good. So now let's get to agents as well. Let's probably demo this using Claude Code. So let's detach from Herdr. Let's go edit our Homebrew configuration to install Claude Code as well. Claude Code is a cask, so let's just duplicate this line and say Claude Code. And we will be rebuilding Nix. Claude Code saves its settings into a settings.json file. So I'm just going to create that. First, the directory, I think it's home/.claude. And then I'm going to create the settings file, settings.json. I'll just leave it as a empty JSON blob for now and let Claude write it when Claude starts. And similarly, we need to create a symbolic link. So we'll do it very similarly here. It's going to be Claude settings.json and Claude settings.json. And that should do it. Let's rebuild. And now let's try to start Claude in Herdr. I'll run Claude here. We'll choose some basic settings here. And I'll log in. I don't do a ton of customizations inside of Claude because most of my setup is deliberately agent agnostic. But one thing I do customize in Claude Code is its status line. So I can monitor basic information like what model is being used and how much of the context window is used. I do this by using the /statusline command in Claude Code and just ask what I need. So I'll say I want to see the model name and percentage of context window used. And Claude will write that for me. Now you can see that Herdr on the left-hand side understands that Claude is working and can display the status in the side panel. Here I'll let Claude run for now. You can replicate some of these things like status tracking with hooks, but it's just really nice that Herdr supports this out of the box and in a consistent way across all the agent harnesses, not just Claude Code. Now we can see Claude has created status lines for us. Let me destroy those panes so it's easier to see. We can see opus 4.8 and context 2% used being listed under the prompt line, which is the status line that we just created. This real-time monitoring is very useful. If I want to see what kind of changes happened so far, I can just split another pane and use Neovim and use NeoGit to see the diff. This is a very typical flow for how I work. Now, a really important piece about working with agents is the global memory file that affects all our agents' behavior. I want all my agents, whether it's Claude or Codex or OpenCode or Pi or Grok or whatever, to behave somewhat consistently and follow my rules. I do this by creating a central memory file. I put it here in my dotfiles repo. I'll put it here, home agents.md. And here is a set of rules I wrote for my agents. Never use m-, use plain dash instead. For some reason, a lot of the AI models are trained to use m- whenever it needs to use a dash. So now whenever I see m-, I just feel really robotic. So whenever I need the agent to write something for me, like a commit message or a PR description, I don't want to use the m-, so that's my preference. When writing commit messages, never auto-add your agent name as co-author. That is something Claude really loves to do, and this system prompt will fight against that. I don't think it's too useful for agents to be like a co-author of the human. It's ultimately still the human that's going to be accountable for the quality of the code change. Never manually modify changelog.md files or any files that are marked as auto-generated. That's a no-brainer. When making technical decisions, do not give much weight to development cost. Instead, prefer quality, simplicity, robustness, scalability, and long-term maintainability. This is a very, very important rule. And the reason I have this rule is that agents, the large language models today, are trained from human data. And when we humans are making estimations about our projects, our estimations are usually in days, weeks, or months. But agents can work a lot faster. But because the agents are trained from human data, it tends to assume the estimation, the development cost, is going to be as high as what humans estimate. So when agents are making decisions, sometimes it will put too much weight onto the development cost and prefer those really cheap and not very scalable solutions. That is bad. So I have this rule here to fight against that, so that the agents don't put too much weight onto development cost and instead prefer the other things that we care about. Here, when doing bug fixes, always start with reproducing the bug in an end-to-end setting as closely aligned with how an end user would experience it as possible. This is also very important because otherwise sometimes the agent will jump into conclusion and start to fix a problem that doesn't exist. So this makes sure that the agent will find the real problem, so the fix will be actually solving the problem effectively. Now, when end-to-end testing a product, be picky about the UI you see and be obsessed with pixel perfection. If something clearly looks off, even if it is not directly related to what you are doing, try to get it fixed along the way. And the last rule is similar. Apply the same high standards to engineering excellence. Lint, test failures, and test flakiness. If you see one, even if it's not caused by what you are working on right now, still get it fixed. These are also rules I find very helpful in holding a high quality bar. Now, I'm going to use Home Manager to distribute this file to all the agents. So we'll come to home.nix and we will be pasting this in. This is creating symlinks into each agent's global memory file location. Claude uses this Claude.md and other agents use different locations as well. So now, after a rebuild, that same global memory file will be loaded by all my agents consistently. And the really cool thing now is the rebuild script can fully reproduce everything we have configured so far, no matter what the current state of the system is. I can now go to a freshly installed Mac, clone this .file repo, and immediately get the entire setup up and running. Alright, this .files repo has now been published onto my GitHub. You now have pretty much the same development environments that I use. It's time to start building. If you haven't come across my previous video about my agentic engineering workflow yet, now is a great time to catch up and see how I actually get work done with this setup. Thank you for watching and see you next time.